Can you hear me well? Yes. Awesome. Hey, everyone. So today we'll talk about Ceph Telemetry project. We'll have an overview of the project, and we'll talk about the motivation behind it, its architecture. We'll have some sort of a dashboard demo. We'll hear some success stories, and we'll talk briefly about how to deploy your own telemetry service. Wouldn't it be nice if we can tell how many Ceph clusters are out there in the wild, which versions they're running, their storage capacity distribution, what drive models they use, what crashes they experience, and what Ceph features they're using, and so many more answers to a lot more questions that we have. This is what we have the telemetry module for, where it allows clusters to phone home and report anonymized and non-identifying data about their installations and configuration. And the data is aggregated and presented in public dashboards at telemetry-public.ceph.com. The telemetry module is built into Ceph. And by default, home is upstream Ceph, but clusters can be configured to phone elsewhere. It was first introduced in Mimic version 13 in 2019, and ever since we see a steady opt-in increase trend from the community, with more than 2,000 clusters that report more than 800 petabytes of total capacity with more than 100,000 OSDs. It's important to emphasize that by default, telemetry reporting is off. Users need to explicitly opt in by agreeing to a CDLA license, and they can do it either with a CLI command with Ceph Telemetry on, or they can use the dashboard wizard to do so. Users can also see a preview of a telemetry report with Ceph Telemetry Show All or Ceph Telemetry Preview All since Quincy. And by default, the telemetry report is compiled daily from several channels, each with a different type of information. And once the user is opted into telemetry, the channels can be turned on or off. Currently, there are 5 channels in telemetry. The first one is the basic channel, which is on by default, which collects and reports basic information about the cluster, like Ceph and kernel versions, the cluster size, number of daemons, and so on. Next, we have the crash channel, which is also on by default, and it collects information of the metadata of the crashes that happened in the cluster. It includes the backtrace, the type of the daemon that crashed, and so on. We also have a device channel, which is also on by default, which collects the health metrics, mostly smart, from all of the drives in the cluster, and some NVMe metrics where applicable. We have another channel, which is the ident channel, which is off by default, and it allows users to identify themselves. Even though everything is anonymized, some users choose to identify themselves, and this channel allows them to provide their name, email, and organization. And in Quincy, we added the perf channel, which is also off by default, which reports various performance counters in the cluster. It is very important for us to emphasize we care deeply about the privacy of our users, and we take several steps to ensure it. Whenever we introduce a new data model version, we require users to re-opt in on a Ceph upgrade. Otherwise, they can send the current opted-in version. Reports do not contain any sensitive or identifying data like pool or host names or object names or contents. We also anonymize the reports. So each cluster is assigned a random UUID, which is specific for telemetry. The FSID is not reported in telemetry. And we also redact the disk serial number, and we never ever store IPs. We took an additional step to enhance privacy by separating telemetry reports into 2 different endpoints. So one is dedicated for the anonymized cluster data, and the other is for the anonymized device health metrics. So this even allows even more privacy. The motivation behind telemetry is both for helping users and developers. So for developers, it is very useful to get feedback on what features are in use in the wild. Should we keep developing them? We also want to learn about the upgrade cadence and the version adoption rate from users. And the device channel helps us to learn about what hard disk and SSD models users are deploying. And in the long run, we're currently creating, and in the long run, we're going to have a really great open data set of device health metrics, which is aimed for research to create more accurate drive failure prediction models. With the crash data, we can learn about how bugs, about new bugs that are happening as soon as possible. And it also helps us to prioritize issues by focusing on the most common bugs. So we can see how many clusters experiencing a specific issue. And it also allows us to discover some trends throughout versions of specific issues. And once we have a solution for an issue that we see in the wild, we can actually verify that the solution works by identifying regressions. I will talk about that shortly. For users can use the telemetry data in order to validate their own installations by looking at what is common. And by opting into the device channel, they're contributing to an open data set of drive health metrics, which is it's pioneering. There's only one company in the market that does that, and we want to create an even better open data set in order to allow research on better failure prediction models, which eventually will lead to preemptive mitigation of failing device to reduce downtime. Another great win for users is that they don't need to actively report issues or open tickets for each crash. The process is automated, and all the crashes that happen in the cluster are just reported to us. And users can also use the open dataset of crashes to better understand an issue. They can view it on our bug tracking system, tracker Ceph.com, and they can learn whether the crash that happened in their cluster, that issue that they're experiencing, was fixed in a specific version. Let's briefly talk about the architecture. So every day, the Ceph Manager daemon collects data from all of the daemons in the cluster, and the data collection mechanism is built into Ceph. And then it compiles the reports, one report for the cluster and the other reports for the device health metrics. And it sends it home to our backend, to telemetry Ceph.com, where we have an Apache server and a PostgreSQL database, and a couple of instances for Grafana, one for the public dashboard and one for the private dashboard. We're going to take a look at the demo. Sorry about that. It's a screenshot. I did not know that I will not be able to connect my laptop. But you can go to telemetry Ceph, to telemetry-public-ceph.com, and you'll see the public dashboard. This is a pretty recent screenshot that you can see that the most popular versions in the wild are Pacific, Octopus, and Quincy. And there are about 844 petabytes total capacity from all the clusters that report. We can also see a breakdown of the versions for the clusters that report. So at the top of the page, you can select a breakdown by major or minor. And here we have a breakdown for Quincy. So we can see the adoption rate for the versions and how users are migrating to the most recent release, the 17.5. It's also useful to understand the volume of the capacity that's coming from the different clusters. So not just the breakdown by the versions and the daemon count, but to see where the most volume is coming from. And currently in the wild for the cluster that report telemetry, most of it is coming from Pacific. We also have this heat map that allow us to understand the distribution by total capacity. So we can see that most clusters report about two buckets, so between 32 to 128 terabytes, so about 200 something clusters. And this is pretty steady through the last 6 months. There are also some very big clusters that report between 16 and 32 petabytes. We can also learn about capacity that the clusters that report are going to need. So this is a dynamic dashboard. It exists on the private dashboards currently that we can look forward to the next 90 days and have a list for all the clusters that will reach an 80% capacity threshold. And looking forward to the next year, we can have this graph to see how many, the total extra capacity for the next year for all the clusters that report, and we can choose the threshold to look at. With the device data, we can see the breakdown by the popular vendors that are out there in the wild, and we can see that currently Seagate is the most popular vendor that users are deploying their drives. And right after that, I believe that's HGST and Western Digital. We can also see a breakdown of devices by interface, either for flash or spinning. So NVMe is, we can see that it's popular as much as SATA for SSDs, and SCSI is a lot more popular than SATA for hard drives. And altogether, we can see devices by type. So mostly hard disks are reported, and SSDs and NVMEs are down below. So that was a breakdown for all devices by type. So for all vendors, we can also have a specific breakdown by vendor if we choose it from the pull down at the top of the page at the dashboard. I want to talk a little about the crashes. So let's look what the crash report contains. So each raw crash report that we receive contained a crash ID, which is a combination of a timestamp and a random UID, the daemon type and name, Ceph version of that daemon, the backtrace, some information about the OS, and the assert message and condition, if applicable. And we can also look at data from the basic channel in case the user is opted in to that channel as well, to see a bigger picture of the cluster that is reporting that specific crash. And now we receive a lot of raw crash reports, and we need to find patterns among them. So the way we do that, we have a crash processor in our backend that identifies the similarities among those different raw crash reports and groups them into signatures by basically sanitizing the backtrace, removing some frames out of it, and cleaning it from addresses and so on, and then adding the assert condition and function, and then digesting it into a signature. The crash processor supports multiple generations or recipes of signatures, which allows for backward compatibility. So in case we want to enhance the recipe and create an even better grouping, because I know that there are some duplicates in the reports right now. So we can keep enhancing the recipe, and we have backward compatibility for that. And then the crash processor populates the database, and then we have database of signatures, which is mapped to raw crashes. But just having the data itself is not enough. We want to bring it to action. This is where the REDMINE telemetry bot comes to place, and the way that it behaves, it queries the database, the PostgreSQL database that we have for the most recent crash signatures, and then it maps each signature to a REDMINE issue. And the way it does that, it searches REDMINE for these signatures, and it updates an existing issue in case it finds one. Otherwise, it creates a new issue with the data of this signature, which contains the affected versions that this signature, the raw crashes of this signature were reported to. And there's also the sanitize and the raw backtrace and the link to a dynamic dashboard. What's nice about the bot is that it also identifies regressions. So in case we have this tracker issue that is mapped to a signature, and let's say that we solve that bug, and now we receive new reports, new crash events with a newer Ceph version that basically should not contain this issue. The bot will open a new ticket in REDMINE and will refer to the original fixed one, and it will give a heads up to developers. We have a very powerful and internal dashboard for the crashes, which allows searching by frames in the backtrace, by major or minor versions, by all revisions of signatures, and assert function or condition. We can see the number of affected clusters for each signature, and to learn about the crash status. We can also have drill downs to cluster information, so we can learn about the capacity of the cluster and the current version that the cluster is running. And we can also see the trends throughout versions. Now, this is another static demo. Excuse me for that. So here we can see that we have a lot of fields that we can search by, what we just mentioned earlier. So here we just wanted to see all the crashes for the most recent Quincy version, 17.2.5. And we can see the number of crashes in a time frame. Here, the time frame is very big, so it is similar to the total number of occurrences that each signature has. We can learn about how many clusters see this issue in their how many clusters see this issue, and the breakdown by major and minor versions. So if we were to click on one of the signatures, we will see a signature page, which tells us when the issue was first and last reported. We can learn about the count of the raw crash events that were reported and how many clusters were affected. We can learn about the status of the tracker issue that is mapped to this signature. And here we can see the sanitized backtrace that is used in order to create that fingerprint. And we can click on each of these frames and to see other signatures that these frames appear in. So if we were to click on one of them, we would go back to the search page, and you can see in the first field we're searching by that specific frame, and there are 3 different crash signatures that contain it. Going back to that page, we have some more information on that specific signature page, such as the assert function and condition. And then we have the daily occurrences. We can zoom in and learn some more. We'll have a list of the affected clusters and lots of information about each of these clusters. And then we have the list of raw crashes. We can filter out by many details here as well. And if we were to click on one of these crashes, we would see a raw crash report where you can see the backtrace and all the metadata of that crash. We have a crash queue and triage custom queries for every project in REDMINE. If you can just see it on Tracker, or if anyone's interested, I can share the links. Just a side note, not all crashes mean Ceph bugs. So there could be hardware and IO errors issues, or environment or resource and config issues. And there could be also issues of other dependencies. So not all crashes are actually bugs. All right, let's talk about some cool stuff we saw. So it is very essential to monitor crashes of new releases, like we just saw with 17.2.5. And here we have examples for bug fixes to crashes that were reported through telemetry and were opened in the Tracker, and they have been picked up by the teams, and there are pull requests and backports that fix those bugs. And this is pretty awesome. This is all automated. The only manual thing here is the fix by our engineers. This is an example. Oh, so actually, I think, yeah, I did have another screenshot for that. So that's an example for the tracker that was opened by the telemetry bot. So you can see that it populates the tracker with all the signatures that are relevant for this issue and all the affected versions. And then it has some example for a raw crash report and a link to the dynamic dashboard where the engineers can look and have some more details. Here there's a pull request that was that had that issue fixed. Sometimes users report manually issues, and the crash dashboard helps us to understand when the issue was first introduced. So in this example, a user was reporting an issue that happened in Quincy, but then with the telemetry dashboard, we could search for that assert condition and function, and we realized that it started as early as Pacific 16.2.5. And sometimes users themselves respond to telemetry crash reports. So the telemetry bot will open a ticket, and users chime in and say, hey, I also see this issue. I can provide logs or any other information that you need. That's very helpful because we cannot always reproduce issues in our own lab. And here's an example for a bug that was fixed. And the latest version that was specified in Tracker was, I think, 16.2.0, if I remember correctly. But then we saw some new crash events from 16.2.5 and 16.2.9. So the crash bot, the crash telemetry bot opened a new issue and gave engineers a heads up saying that issue was fixed, but now we're seeing new reports from newer Ceph versions. So you might want to take a look. And like we mentioned, we have the ident channel. Sometimes users want to identify themselves. So we contact them when we need more information about crashes that we want to that we need additional logs or anything like that. And I'm very happy to share that users are more than happy to help on that. We also use telemetry in order to understand how features are used in the wild. So, for example, it helps us to understand whether we can announce file store as deprecated. We had, did I add this one? Yes, I did. Okay, so we had a full dashboard that has a lot of analysis of what we see in the wild for the breakdown of file store versus blue store usage, and we saw that it is pretty safe to announce that file store is being deprecated. We also wanted to know about the Erasure Code Clay plugin, whether it's being used in the field. So we could check that with telemetry as well. And we wanted to know whether there are crashes that are related to this plugin. And thankfully, there were not. And again, this increases observability and let us understand how Ceph is being used. Yeah, and the dashboard team needed some help in tuning. They wanted to understand the magnitude of RBD images that are deployed in the wild, and this information was essential for them as well. We have a dashboard for that, but I did not have a screenshot, I'm sorry. All right, okay, 2 more slides. Let's say that you want to deploy your own telemetry service, and the reason for that would be that sometimes you might have constraints. The cluster can be air-gapped, or you want to have some more observability in your own fleet. You need to do 2 things. You need to bring up a telemetry server and to configure the telemetry module. So in order to bring up a server, you'll need the Postgres database, the web server, and Grafana. And we have a detailed install guide in our repo. And for the telemetry module side, you'll need to change the endpoints because right now they phone home to upstream Ceph. You'll need to opt in because telemetry is never opted in by default. And you need to enable the channels that you want. You can do that either with the orchestrators like Ceph ADM, or you can change the modules default when you build Ceph. Or you can do that at runtime. If you have a running cluster and you need to do that now, you can just config the manager module. please contribute, please join us, and opt into telemetry. Yeah, I know we're over time, but if you have any questions, be happy to take them.
At least most of our crashes are based because of hardware failures. How do you distinguish and filter for that? Like you probably don't want to open bugs for every hardware failure.
Yeah, great question. So we do have IO errors that we report that with the crash metadata. So we just filter out all these crashes, and we do not open tracker issues for them.
A follow-up question on that. Regarding the device health metrics that are being captured, there is a device failure protection also that is, you can either set it off or local. Like, how efficient was local to be proven? Because like we have tried turning it on certain clusters, but although there was so many crashes, like none of that was actually like really helpful. I mean, we haven't seen any alerts from the Ceph side. So is there an effort to increase that local database to like understand more predictive failure scenarios?
Yes. So predicting a drive failure is not simple. All like the different vendors have specific metrics, and there's no like one size fits all prediction model. Of course, there are different types of drives, like flash and spinning, and we need many models to cater to all of them. We do not have information about how well the disk failure prediction module is functioning in the wild. But we are working on improving the models. We're collaborating with vendors and working on collecting some more vendor-specific metrics in order to improve that.
So I have a question about the performance channel. I don't think it was covered too much in this presentation, but that's like highly interesting to me, and I wonder if that was enabled, if there's any overhead, and if so, how much overhead it's gonna bring?
So first, we're in the process of analyzing the metrics in our backend, and about overhead. So you mean in generating and compiling the reports and collecting? So from our experience, it can take a short while to compile the report, but there shouldn't be. It happens daily, and it should not interrupt basically the cluster's operation. And we're talking about really big clusters. Otherwise, it shouldn't take that long.
We had a lot of conversations actually about trying to make sure. Thanks. We had a lot of conversations on the OSD side about how frequently we gathered some of that data, and it was actually a really big concern making sure that that was impactful. So I think hopefully we're in good shape, right, Yaarit?
Yeah. Yep.
Cool.
Thanks, Mark.
So the graphs are really great. I noticed, one of the graphs we showed the minor versions and how like 17.2.0 slowly shrinks in terms of usage. As we go forward in time, does that include clusters that have stopped reporting, or does that only include clusters that are reporting at that given time period?
You mean like the 17.0 graph?
17.2.0, 17.2.1, 17.2.2. And we see, as we go forward in time, most clusters are on the latest version of version 17, but there's still some clusters that are on 17.2.0. So it brings to mind the question, are those clusters the ones that originally reported early on in the 17 life cycle and they just stopped reporting because they went away for whatever reason? Or are they still reporting that they're using that version?
I believe, and I don't have the exact breakdown for this specific version, but we could look at that. I believe that these are the original clusters that were reporting all the I find it hard to believe that these are new clusters that started reporting to telemetry with this version, but it can happen. So we don't have a differentiation on the dashboard to see like when they joined, started to report, or whether they upgraded to a different version. But it's a good question. I'll be happy to take a look at that.
So kind of related to that is, you know, it's not in the data, but it would be interesting to see like cluster retention. Like, do we get reports from a cluster? How often do we, you know, get continual reports, or do they just disappear? You know, similarly, I think that has an important impact on like drive disk prediction,
Yes.
right?
Yep.
You know, you can't declare the drives died if the cluster disappears. You know, things like that.
Right. Yeah, that's a very good point. Yeah, we should add a heat map with like a time series histogram for retention days for clusters.
Sorry, I'm monopolizing questions. One last one. We did the air gap clusters, but is there going to be any capability to have manual reports done from clusters who want full control over the data that may be shared with telemetry?
So we were talking about that as well, of having an offline telemetry capability. Even Mark, we discussed that at some point, like having a thumb drive for air-gapped clusters that they can just choose what and when to report. Yes, so this is something that we discussed we might implement.
No, Mike, I already got authorization for one last question. It's a good one. Look, Backblaze and now Digitech, a Swiss electronics seller, get a lot of publicity publishing reliability statistics, warranty rates for products. I mean, Ceph could get a lot of publicity if we make some kind of public report about the reliability and maybe performance of different drive models. But I understand this can be also a bit of a delicate thing for us to publish. What are the limits of what we can do there?
It's a very good question. I think for a start, we want to use this open data set in research and see what we can learn from that, because one thing that we are missing is the labels. We don't know whether a drive was actually failed. We can just say that the host is still active, but that drive is no longer reporting. So that's a pretty good heuristic to understand that something happened to the drive. So we're now in the process of playing with this database and getting some more insights from it. And yes, definitely when we have some good insights, we want to make it even more public because that was the reason, that was the idea behind it, to have some more models and vendors open drive health metrics data set. Yeah. I guess the next question is when's lunch? So yes.
Let's hear it for Yaarit.